Hi, I am Sahaja Priya and my teammate is Satya Sai Priya. Our group number is 23. Now we are going to give presentation on mastering the game of Go without human knowledge using deep neural networks. Next slide. Introduction. In AI research, the game of Go is often used as a source. The larger board allows for 360 crossings, which makes it hard for the AI to find a good move. This makes it more difficult for the AI to find a good move. When you play Go, you have a lot more room to look for the right move when you play chess. People play chess on an 8 by 8 board, which makes it easier to find the best move for any board arrangement. Next slide. So, we came to the approach called Monte Carlo tree search. AlphaGo ability to mix neural networks and MCST is the main reason it has been so good at beating humans at games. The use of neural network also helps with the use of reduction principles. It lets us cut down on the depth and breadth of the tree. When it comes to training, AlphaGo has a unique pipeline with a lot of different steps. To get the best accuracy and efficiency, we use SL, that is supervised learning and real life learning. On the slides we see an example of the process we talked about earlier with a neural network training pipeline and architecture. So coming to supervised learning of policy networks, people are using supervised learning to predict the moves of experts in the game of Go during the first phase of the training pipeline. This builds on the previous work. There are convolutional layers with the weights and non-linearities in supervised learning policy network. The last softmax layer makes a probability distribution that includes all the possible moves. All the information that goes into the policy network is just a simple summary of what the board is doing right now. The policy network can be built using supervised learning and then used at random to guess how experts move in a data set of positions. By combining self-play games with a RL policy network, a whole set of new data is made. Value networks are then trained by regression to predict what will happen next if they are used to sample state action pairs. This is called stochastic gradient ascent. Next slide. Reinforce learning of policy networks. To improve the policy network, the second stage of training pipeline uses reinforced learning with policy gradients to improve it RL. The RL policy network P has the same design as the SL policy network, which is why it works the same way both. A graph that shows how well policy networks can be trained as a function of how well they can play. The winning rate of the policy network against the match variation of the policy network was shown. During the training, policy networks with 128, 192, 256, and 384 convolutional filters per layer were often looked for. Next slide. Reinforcement learning of value networks. So, VP of S is a value function that predicts what will happen in the game. Starting from a position S with a policy P for the both layers, this is the last step of the training process. In a real world or ideal world, we would know the best value function V star S for the perfect play. In reality, we use the RL policy network P to figure out the value function VP for our strongest policy. This neural network is built the same way as a policy network, but instead of making a probability distribution, it predicts what will happen to a certain person. Stochastic gradient descent helps us in train the weight of the value network by moving backward on the state outcome page, S comma Z, and cutting on the mean square error between the predicted value V of S and the result Z. Next slide. Coming to searching with policy and value network, AlphaGo MCTS algorithm is made up of policy and value networks that use look ahead search to choose actions. The value network and the rapid rollout policy both check each edge twice. The value network checks each edge once with a value network and once with the rapid rollout policy to run out a rollout until the game ends, and then calculate its results using the function R. All the evaluations of R and V in the subtree below that action looked for add by the action values Q, which keep track of the average values of all of them. S comma A nodes now has the action value Q and how how many times it has been visited n. It also has a probability p, which is how likely it was to have done this before s comma a. The tree is walked through in a simulation, starting the route that is in descending order tree in an entire game without backup. At each step, each simulation chooses an operation from the state st that has been in for the time step. At the end of the simulation, all of the action values and visit counts for the edges that were crossed were updated. It is done at the each edge. The number of simulations that have been passed through and the average rating of those that have passed through together at each edge. Next slide. So coming to my final slide of methods. In many games like chess, Othello, and Go, there is a lot of information. They are used alternating Markov games 39. S is the current player to play a state transition function. F f of s comma a defines the next state after a player chooses an action in the state and gets random input. For example, dice, and a reward function of r of s, which describes how many money the player gets in the state A after taking that action. So the state space is a of s f of s comma a equal to f of s comma a, and there are no rewards except at the end of the game. We look at the player zeros, some games, and deterministic transitions. The game outcome is the reward at the game end from the point of view of the current player at the time step t. When people talk about policies, they are talking about the probability distribution over lawful action that is called A of S. So, the optimal value function V star S is the same for all the zero sum games. If both players play perfectly, the outcome from the state S will be the same when the function is used. The next slides will be continued by Cypriya.
Thank you, Sahaja. My name is Priya. Today topic is mastering the game of Go without human knowledge. In this with game of Go without knowledge, in this Alpha Go, for good reason, the game of the Go is a space complexity, making the difficult of AI and good move. It is a comparison to chess. Go has a much larger search space in order to perform the correct type of move. Chess, for example, has a board. This is 8 and 8, and thus has a much smaller search complexity, allowing us to make the move-to-move arrangement of the board. The calculation of the large finite with Go, however, the amount of closer to finite. And coming to the next slide, it's AlphaGo 0. This is when it comes to search space. Main principle is to be, according to Pepper, we can easily reduce the by implement of the concept of the position evaluation and tracking the tree and replacement the subtrees in order to achieve the good probability of the result, and to allow us to generate the probability of distribution from which can be determined the moves are available for our current positions. And coming to the neural networks, AlphaGo ability to made a multiple stages, and this is to decrease the both depth and birth of the tree. When it's come to training with AlphaGo, we perform the it uses specific pipelines, and it's made the multiple stages. And coming to the Monte Carlo research, it's a MCTC. One of the policy, another value of the network. We can use how to process the carrier the deep neural network. So research we were focused to employ the asynchronous multiple thread searches for simultaneously CPUs. Further, they use it to GPU in parallel to compute the both networks. In combine all concepts of such a reinforcement learning, supervised learning, and two main principles, policy and the value networks. Deep learning and the more of the ideas, AlphaGo, a powerful of artificial intelligence. And coming to next slide, this MCTC, there is a state space phi. It's an action to any states as the state transaction f of s comma a, that defines the successor state after selecting the action and state to randomly took inputs. So, for example, dice. And finally reward the function of rf f of s comma a equals to f of s comma a, and it's zero payouts export to the terminal time steps. Coming to next slides, it's a method self play game. Method self game is nothing but search tree became a high probability movements, and towards to high probability moves, this MCTC is also combined with a value function which is used to determine the action values in newly expand the combine of Carlo maximum evaluation 49. This based on trusted Monte Carlo search method, which stops rollout before the games and end of the use of value function place of the terminal towards. And coming to next slide, self-play re-informative learning in AlphaGo Zero. This is self-play and a neural network training. This decreases of both depth and birth search tree, which it comes training with the AlphaGo performance. It's using the specific pipeline with the multiple stages, and you can also use SL. SL means supervised learning, and RL reinforcemental learning to achieve the highest accuracy and efficiency. And coming to next topic, empirical analysis of AlphaGo Zero training. This is these handicap rules were used except the distribution AlphaGo. Each computer Go perform was run by a single mission, which indicate the specific using most recent available version in the best hardware configuration allowed the program. And AlphaGo won the game 5-0 and the 3-2, and official game had one more time limit. And coming to the next performance graphs, this graph is mostly indicated to 20 reducible blocks, and beginning with the f of a, the performance of AlphaGo during self-reinforcement learning is depicted to the scale of the function training. And this the result were surprised involved the AlphaGo Zero outperformed AlphaGo Lay after 36 hours of training, despite the fact and Lee has been to train several months, and similar to AlphaGo Zero was tested all together to all sites. And this is the architecture of NN and neural networks. This is also this figure depict the graph gradually implementations, and AlphaGo Zero finally performance was then put the test to internal terminates against the AlphaGo fans and AlphaGo Lee, the strongest existing program AlphaGo masters. The tournament rule was the only 5s of thinking per move were allowed, and the AlphaGo and AlphaGo masters each played the 4 TPs, and AlphaGo fan is AlphaGo the lead, and according to the result of the experiments. And coming to the next slide, this is discovering and discarding the human Go knowledge. This is the Go chess board. In this Go chess board, it clearly explained the graph sections. And this sophisticated understanding to Go concepts such as opening, life of death, operated board situation, and capturing the race, sense, and Yosh shape influence the territory. All discovery form of first principles, despite the fact of capture sequences, and this element the Go knowledge learned by the humans. AlphaGo you understand it much later than this the trainings. And coming to the conclusion, current value of function generate the better policies, and a neural network policies, the policy evaluations accomplished throughout the policy in the self-play games are projected backing into the functions. And coming to the compare to the training on human expert data in this divided to two topics. This is achieve better and asymptotic performances, and finally the AlphaGo Zero is able to as well as novel strategies. Yeah, thank you Sahaja.
Thank you.